In number 35, we have ln of this expression, and we want to expand using our log properties. So first we'll use the fact that the log of a quotient is the log of the top minus the log of the bottom. So let's do that. So we have the log of the top minus the log of the bottom. And now let's expand this. The log of a product is a sum, the sum of the logs. So we have the log a cubed plus log b cubed here. And now we can also bring down, use the third log property to bring down all these exponents. So this would be 3 log a. We can also pronounce that ln a. 3 ln a plus 3 ln b minus 5 ln c. So that's what we mean by expand. Okay, here's another ln expression to expand. And we'll do ln of the top minus ln of the bottom. And now let's expand this product over here. Ln AB is ln A plus ln B. Here you have to be a little bit careful. And I'll show you where. Alright, let's keep the sum in parentheses, because this negative is going to apply to the entire sum. So we have to be careful there. Plus. Alright, because we're going to have minus the first term and then minus the second term. So that's why I keep the brackets on here. Okay, now let's just bring down the exponents. Now this square root is the same as exponent 1/2, so we'll put 1/2 in front. Okay, and keeping the brackets on, we can bring the 5 down. And bring the 4 down. And that's it, that's expanded. Now we're going to do the opposite of what we did in the previous problem. We're going to actually condense this time. So first let's bring up those exponents. So I'll bring the 5 up and put it here. And bring the 2 also up to the exponent. So that'll be squared, and bring up that 7 as well. Okay, now we have here log 3x minus 2 to the 5th plus this log. So those will be multiplied in the numerator. And then this has a negative in front, so that'll go in the denominator. Okay, and that's condensed. Okay, find the exact value of ln e squared over the square root of e. So start by expanding. So here we have ln e squared minus ln square root e. Now bring the 2 down, 2 ln e, minus, now this square root is exponent 1/2, bring that down, minus 1/2 ln e. Okay, ln e, that's the log base e of e. Well, the exponent of e that, such that e to that exponent is e, is just 1. So the log base e of e is 1. So this is 1, and this is 1. So we actually have here 2 minus 1/2, which is equal to 3/2. Every log equation of this form can be written as an exponent equation, an equivalent exponent equation. So here's the equivalent exponent form. This is the base, this is the exponent. So 2 cubed is equal to this, 2x plus 1. Alright, so that's just a simple linear equation. Subtract 1, and we have x is equal to 7 over 2. Here we have an equation that looks very simple, and the way we were solving these before, earlier on in the review, was we attempted to write the right-hand side as a power of 2, and we matched exponents, but we can't write 5 as a power of 2. So this is done a different way, and we simply use log properties to solve this. When we have an equation with x in the exponent, it can be solved using log properties, specifically the third property that says that if you take the log of some exponential expression, you can bring the exponent down in front. So we'll do that. We'll take the log of both sides. We can use either log base 10 or ln. Let's say this time I use ln because those are both available on our calculator. So that's why we use either one. Okay, I'm going to use ln. And the only reason why we did this is so that we could use the log property that says that this exponent comes down in front. So that would be x ln 2 is equal to ln 5. And now we can solve for x. X is equal to, just divide both sides by ln 2. X is equal to ln 5 divided by ln 2. And we'll just look up these values on the calculator, on our calculator. Okay, so we have, let's see, ln 5 is 1.609. And then let's do ln 2 is 0.693. And just divide those. And we get that x is equal to 2.32. And let me just say that that solution seems reasonable because I know that 2 squared, 2 to the exponent 2, is equal to 4. So I want something a little bit bigger than 2. I would expect that some number a little bit bigger than 2, slightly bigger than 2, will give me 5. And that's what we have here, 2 to the 3.2. This is similar to our previous equation, except we have this 3 in front. So let's start by dividing both sides by 3. So we have 2 to the x is equal to 5/3. And then we want to solve for x. X is in the exponent, so we'll take advantage of our log properties, log both sides. And we're doing that just so that we can bring the x down in front over here. All right, so x ln 2 is equal to ln 5/3. And then divide both sides by ln 2. And we have x is equal to ln 5/3 divided by ln 2. And we just get these values from our calculator. Okay, so let's see, we have ln of 5/3, I have 0.51 approximately. And then ln 2. And we have 0.693. Okay, so just divide those. And we have approximately 0.74. So once again, we have an equation with x's in the exponent, and we want to bring those down. And once again, we're going to ln both sides just to bring those down. All right, so here we have on the left, just bring the entire x plus 1 down. So we have x plus 1 times ln 3. Remember, ln 3 is just a constant, is equal to bring this x down in front, x times ln 5. Okay, now multiply out by ln 3, so we have x times ln 3 plus ln 3 is equal to x times ln 5. And we're going to gather together the x terms just like we always do when solving for x. All right, so let's say I'll subtract x ln 3 from both sides. So on the left-hand side, we have ln 3. And I'm subtracting x ln 3, so I have x ln 5 minus x ln 3. Okay, so continuing to solve, I want to solve for x, so I want to combine these. So let's just factor out the x. So now I'm able to solve for x by dividing by what's in parentheses here. So x is equal to ln 3 divided by ln 5 minus ln 3. Now this answer is acceptable, but if you want, you can just evaluate that. You can figure out what that's equal to. Okay, so let's do that over here. Okay, so with our calculator, we'll figure out that ln 3. So I get for ln 3, I get 1.0, approximately 1.1. Okay, so it's 1.1 for ln 3. Okay, so I have ln 3 in the denominator as well. And let me fill in the ln 5 now. Okay, so I get 1.609. And then you just work that out. Okay, I get about 2.16 for x. So that's so it is an approximation. If you wanted to do a check, let's just do a check here. We might as well. So we'd have 3 to the x 2.6 plus 1. So 3 to the 2.16 plus 1, that's 3.16. 3 to the 3.16 is that approximately equal to 5 to the 2.16. So these you have to evaluate on your calculator. So let me do that. 3, you have an exponent button on your calculator. Okay, I expect this to be bigger than 27, which it is. I have here 32.188. So is that approximately equal to 5 to the 2.16? So let's do that. 5 to the 2.16, doing it using the exponent button on your calculator. And I get, on the right, I get 32.34. That's close enough. So that's my check. Number 43 is very similar to the previous one. Okay, we have 2 to the x equal to 5 to the x plus 1. And log both sides again to bring down the x's, to bring down those exponents. Okay, this comes down in front, so I have x times ln 2, and then this comes down in front, x plus 1 times ln 5, and pretty much we'll do the same thing we did before. Multiply through, and we have x ln 5 plus ln 5. We want to gather together the x terms, so let's subtract this x ln 5 from both sides. Alright, so I'll write this as simply x ln 2 minus x ln 5 on the left-hand side and equal to this ln 5 on the right-hand side. And now gathering together, and then I want to basically combine these like terms, so I'm going to do that just by factoring out the x. So we have x ln 2 minus ln 5. And we'll divide by the expression in the parentheses. So x is equal to ln 5 divided by ln 2 minus ln 5. Okay, once again we'll work this out. And we have 1.609 for ln 5. And for ln 2, we had 0.693. Okay, so let's figure that out. And I get here minus 1. I'll round this off 1.76. Sorry, that's minus 1.76. And again, if you want to do a little check, you can. Let's do that. Let's do 2 to the minus 1.76. And we want to see if that's equal to 5 to the, here we have 1 plus minus 1.76 would leave us with minus 0.76 in the exponent. So let's use our exponent function on the calculator. And we have 2 to the minus 1.76. Let's see, I get 0.295. And we want to know, is that equal to, or approximately equal to, 5 to the exponent minus 0.76. And here I get 0.294. So that's close enough because of the rounding that we did here. So the answer does check. Okay, here again, we're going to take the ln of both sides, but this one we have to be a little bit careful because the x's we're going to bring down the x plus 1 on the right hand side, but on the left hand side, look what we have to do. Here we have to first use the first log property to split this up, to split up this product. So let's see what I mean by that. So this is ln 3 plus ln 2 to the x. So we're using the fact that ln AB is ln A plus ln B. Okay, here I'll bring down the x plus 1. All right, and I can bring down the x in this second term here. So I have ln 3 plus x ln 2. Now multiply through here x ln 7 plus ln 7. Now let's bring the x's on one side of the equation, and let's say subtract ln 3 from the other side. Let's first subtract x ln 7 from both sides. So I'll have a ln 3 plus x ln 2. I want all the x's on one side. Okay, now let's get rid of this ln 3, just subtract it off. So I have ln 7 minus ln 3. Now I want one x term here. I want to combine these. I'll do that by factoring out the x. Ln 2 minus ln 7 over here. And finally divide by what's in parentheses, and basically we're done. All right, so that was a nice exercise in using log properties. All right, I might as well finish this. Let's let's work this out. So we have ln 7. Okay, so that's 1.946 minus ln 3. $1.097, and here we have ln 2, .693 minus ln 7, that was 1.946. Okay, so working all this out, okay, we have in the denominator I get a minus 1.253, and the numerator I get 0.849. All right, so let's just continue it over here. So that's equal to minus 0.677. All around at minus 0.678. Okay, so that's what I get for x.